Welcome to The Debate. Today, we are fundamentally dismantling the way we think about the scientific method, which is quite an undertaking. We are usually taught that science is, a pyramid. It's this steady vertical accumulation of truth. But the source material we are discussing today proposes a very different and honestly a much more anxiety-inducing metaphor. It frames science as a Sudoku puzzle, is that modern cosmology has essentially committed the cardinal sin of puzzle solving. We have inked our numbers too soon.
The argument is essentially that by treating early hypotheses, like, say, the speed of light being an absolute constant, or the fundamental nature of gravity as unshakable laws, we have boxed ourselves into a corner. And now, rather than admitting the corner is wrong, we are just filling the remaining squares with increasingly absurd numbers just to make the grid look complete.
So the core question we are debating is this. Is the current model of the universe, with its dark matter, dark energy, and inflation fields, is that a triumph of complex discovery, or is it a logic that has collapsed? A structure held together by patches and mathematical glue because we are just too afraid to erase the foundation? I argue that our refusal to keep our options open has led to a cosmology that is 95% invisible invention and only 5% observable reality.
I argue that what you call, premature certainty is actually the necessary establishment of reference frames. You cannot build a model of the universe on infinite malleability. The complexity we see today isn't a sign of failure. It is a sign of resolution. To erase the fundamental laws of physics now, based on this critique, would be to trade a working GPS system for a philosophical map drawn in crayons.
Okay, let's start with that Sudoku analogy, because it really exposes the mechanism of the error in a way that feels visceral. Anyone who has played Sudoku knows how logic relies on the integrity of the whole, right?
Mm-hmm.
If you place a 5 in the top corner, it dictates what can happen in the bottom corner. If that 5 is correct, the puzzle resolves beautifully. Every row, every column sings in harmony.
Correct. It is a system of interdependence. If the logic is sound, the puzzle essentially solves itself.
Right, but here is the terror of the puzzle. If you ink that 5 based on a hunch, or maybe just because it looked right at the time, and it turns out to be wrong, you don't find out immediately.
No, you don't.
You might fill in 20 more squares quite comfortably. The logic flows. You feel smart. But eventually, 10 rows down, you hit a block. No number fits. The puzzle becomes literally impossible.
And in this metaphor, the block represents the anomalies we see in modern physics, like the expansion rate of the universe not matching our standard predictions.
Precisely. And this is exactly where the behavior of the scientist matters. A Sudoku player, realizing the grid is broken, erases the work and goes back to the source of the error. They look at that first 5. But the source material argues that modern science does the exact opposite. When we hit that block, we don't erase the 5. We invent a 13. We force the grid to accept a value that shouldn't even exist because we have inked the foundation so heavily that we treat it as sacred.
I understand the metaphor, and it is a clever bit of rhetoric, I will give you that, but I have to push back on the implication that scientific laws are merely hunches we just jotted down in pen. We didn't just guess that the speed of light, c, is a constant. That ink dried over a century of rigorous experimentation, from the Michelson-Morley experiment to modern particle accelerators. These aren't casual scribbles. They are the reference edges of the puzzle. Without fixed edges, you aren't solving a puzzle. You are just staring at a blank page.
But are they edges or are they boundaries we imposed? The source challenges the ink status of C directly. It suggests that by defining the speed of light as a universal constant, we created a rigid grid. Now when we look at the edges of the universe and things don't match that speed or that expansion rate, we don't question C. We question the universe. We say space itself must be expanding faster than light, or time is dilating. We bend reality to save the constant.
We don't bend reality. We refine our understanding of space-time. That is not a patch, that is general relativity. And it works. It predicts planetary orbits. It predicts black holes. It corrects the time on your phone's satellite navigation.
Does it work on its own, though, or does it require invisible help? Because this leads us directly to the patches. If your theory is robust, it should explain the observations naturally. But the standard model currently relies on entities that have never been seen, touched, or measured directly. We call them discoveries, but the text calls them apologies for for earlier guesswork. I am talking about dark matter and dark energy.
I suspected we would arrive here. Look, science is the process of inference. When we looked at the rotational speed of galaxies, the visible matter, the stars and gas, it simply wasn't enough to hold them together by gravity. They should have flown apart like a spin art canvas. We didn't invent a ghost. We inferred that there must be mass we cannot see holding it together. We called it dark matter. That is a logical step, not an apology.
It is a logical step if and only if your understanding of gravity is inked as absolute. If gravity functions exactly as Newton and Einstein said, then yes, sure, you need invisible mass. But what if the ink of gravity is wrong? What if gravity is a local consequence, not a universal cause? Instead of considering that, we invented a substance that makes up 27% of the universe, interacts with absolutely nothing, and cannot be detected. Then we found the universe is expanding too fast, so we invented dark energy to make up another 68%.
You're dismissing these concepts as fictions, but they fit the mathematical models precisely. They balance the equation.
That is the Sudoku science trap. If I write a 13 in the box, the math adds up, but it is still a 13 in a 1 through 9 game. The source argues that we have effectively constructed a universe of the gaps. We have a theory that explains 5% of the universe, normal matter. And for the other 95%, we have a placeholder label that effectively says, here be dragons. We are wedging and shimming the theory to keep the foundation from crumbling.
I think shimming is a profoundly unfair characterization of high-level physics. Let's talk about Occam's razor, because skeptics love to wield it against dark matter. Occam's razor says the simplest explanation is usually right, but it doesn't say the universe is simple. It says we shouldn't multiply entities without necessity. The standard model is complex because the universe is complex. Renormalization in quantum mechanics, which I assume is what you mean by wedging, is a sophisticated mathematical tool to deal with infinities. It is not cheating, it is calculus.
The source material is quite savage about renormalization, actually. It calls it epicycles with new branding.
We are adding complexity to protect the ink of the Big Bang and standard gravity.
That is a powerful rhetorical parallel, I will admit. But the fundamental difference lies in the convergence of evidence. Ptolemy only had visual observation. We have the cosmic microwave background. We have gravitational lensing. We have the Large Hadron Collider. This isn't just a guy looking through a tube. These patches, as you call them, are cross-verified by completely different fields of physics.
Are they cross-verified or are they cross-contaminated? Because if all those fields share the same flawed reference edge, the same value for C, the same assumption of gravity as a fundamental force, then of course they will all agree on the error. This brings up the builder metaphor, which I find even more damning than the Sudoku one, the concept of tolerance stacking.
Small deviations are acceptable individually, but catastrophic when combined.
Exactly. A carpenter cuts a board a millimeter short. It's fine. The drywall is a degree off. It's fine. The structure is unloaded, standing idle. Science congratulates itself during this idle phase. Look, the building stands, but the universe places a load on the theory. We try to reconcile quantum mechanics with general relativity. That is the stress test, and the structure sags. The errors compound.
And you believe the current crisis in physics, the inability to unify gravity and quantum mechanics, is this sagging?
It is not just sagging, it is groaning. And what do? We don't check the foundation. We don't ask, is the floor level? We assume the floor must be level because we inked it that way. So we blame the walls, we blame the ceiling, we add more drywall, more theoretical particles, more dimensions just to hide the cracks. The source is we are shimming the universe to fit the blueprint.
But let's look at the alternative here. You are suggesting we tear the building down. That is the necessary implication of erasing the ink. Do you realize the chaos that would ensue? If we declare that C is variable or that gravity isn't fundamental, we lose the standard model, we lose the lambda CDM model. We go back to the Stone Age of physics. We need reference edges to function. You cannot navigate a ship if you decide north is a variable concept.
But if north shifted and you didn't update your compass, you would crash the ship. That is the point. The fear of starting over, the chaos you describe, is exactly what keeps the error alive. The source calls this jurisdiction.
Jurisdiction? That sounds highly legalistic.
Yes, science has become a legal system. The laws of physics are treated like statutes that cannot be overturned, only amended. And the language, the mathematics, has become the ultimate gatekeeper.
Now hold on. Mathematics is not a gatekeeper intended to exclude. It is simply the only language precise enough to describe the phenomena. You cannot describe the curvature of space-time with poetry. You need tensor calculus.
But the source argues that the math has become a defensive smokescreen. When a theory starts failing, the math gets denser. It gets more arcane. It moves farther away from physical reality into abstract manifolds. It effectively says to the layperson, you can't possibly understand this, so just trust us. But the text makes a brilliant populist point. You don't need to be a doctor to know you are in pain, and you do not need a PhD in theoretical physics to look at a model that requires 95% imaginary matter and say, something is wrong with this picture.
That is a seductive argument, but it borders dangerously on anti-intellectualism. Our common sense has evolved for hunting on the savannah, not for understanding quarks. Common sense tells you the Earth is flat. Common sense tells you time is constant everywhere. Both are demonstrably wrong. Relying on intuition to judge the cosmos is exactly why we spent thousands of years thinking we were the center of the universe. Mathematics is the tool that breaks the illusion of common sense.
Or it is the tool that constructs a completely new illusion. If I have a variable that doesn't fit, and I multiply it by a complex imaginary number, I can make it fit. Did I find truth, or did I just balance the equation? The source suggests that math should follow the concept, not the other way around. If the concept is force, and force requires dark matter to work, maybe the concept of force is the actual problem. Which leads to the alternative proposed in the material, the E-motion model.
I found this to be a massive pivot in the text. It attempts to replace the inked assumption of force with a completely new pencil sketch.
It is a paradigm shift. The standard model treats motion as the result of forces. Things are pushed, pulled, attracted, repelled. It is very Newtonian at its heart. The E-motion model suggests that motion is permitted.
Permitted? It sounds very passive.
It is structural. Think of it this way. In the current model, a planet orbits a star because gravity is pulling on it or space-time is curved and guiding it. In the E-motion model, matter doesn't move because it is forced. It moves because the field grants it a lower resistance route to a neutral balance. It is like a Tetris block. The block doesn't fall because the top of the screen pushes it. It falls because the space below is open. It is permitted to move there.
I say the conceptual distinction, but I struggle with the practical utility. We already have the principle of least action in physics. We have Lagrangian mechanics, which describes systems evolving to minimize energy. Is E-motion actually a new theory, or is it just rebranding existing physics with softer language?
The difference is in the causality. If you view gravity as a pull, a force, you look for a graviton particle. You look for mass causing the pull. If you view gravity as a consequence of permitted balance, you stop looking for the graviton. You stop looking for dark matter to generate the extra pull. You realize the galaxy isn't spinning too fast. The permitted path simply allows that speed. It refrains the grid entirely. It erases the ink of force and pencils in permittance.
But does it solve the puzzle? That is my ultimate critique of this entire pencil philosophy. It is very easy to stand on the sidelines and say, your grid is flawed. It is much, much harder to propose a new grid that explains the spectral lines of hydrogen, the precession of Mercury, and the expansion of the universe all at once. If we replace our current ink with this E-motion pencil, are we actually getting closer to truth, or are we just trading a precise map for a vague feeling?
That is the beauty of the pencil, though. We don't have to commit yet. The problem isn't that we don't have the perfect answer today. The problem is that the current scientific culture, the funding, the careers, the institutions, actively discourages looking for a new answer.
That is a rather harsh accusation. You think physicists are actively suppressing truth?
I think they are suppressing risk. The source mentions that cosmology is operating under funding and career preservation. Imagine you are a grad student. Do you write your thesis on a radical theory that suggests Einstein was wrong about C? No, you will never get a job. You write a paper that adds a tiny refinement to the dark matter model. You shim the existing theory. The system rewards those who protect the ink, not those who use the eraser.
I will concede that the sociology of science is a real factor. Scientists are human, we have mortgages, and yes, the publish or perish culture heavily favors incremental progress over radical demolition. It is incredibly hard to get a grant to disprove the theory that the grant giver built their entire career on.
Exactly. It becomes a jurisdiction. We accept the reference edges not because they are inherently true, but because they are the rules of the guild.
However, I would argue that the exclusion of radical ideas is often functional, not malicious. We have limited resources. We bet on the horse that has won the most races. The standard model has won thousands of races. It explains the semiconductor in your computer and the GPS in your phone. It is not unreasonable to keep betting on it until a new horse actually proves it is faster.
But if the race is rigged, if we only count the laps that fit the model and patch the ones that don't, then the horse isn't winning. We are just moving the finish line. Dark energy was a moving of the finish line. Inflation was a moving of the finish line.
If we adopt this Sudoku science view, where every number is suspect and every law is temporary, do we ever build anything?
The source material leaves us with a profound warning. The tragedy isn't that the prevailing model might be wrong. We have been wrong before. Being wrong is just part of science.
Agreed. Falsification is the absolute heart of the method.
Right. So the tragedy lies in denying the logic to be questioned. The tragedy is locking up the erasers. When we prioritize the preservation of the model over the clarity of the logic, we aren't scientists anymore.
Intellectual humility is vital.
A healthy scientific method must allow for erasure. If we cannot erase, we aren't doing science, we are performing dogma.
I suppose the balance lies in the tension. We need the ink to build upon, to create the technology and the frameworks we use daily. But we absolutely need the pencil to sketch the future. If we ink too soon, we are trapped.
The source ends with a sentiment we can both agree on. Good science keeps the pencil sharp and the ink on hold.
Indeed.
Thank you for listening to The Debate.
Until next time.